Welcome and thank you for joining this Fluke Thermal Imaging web seminar. This session focuses on the use of thermal imaging in electrical applications. We'll start out by reviewing the basics of thermography. Next, we'll dive right into the use within electrical applications. There will be a short section on using thermal imagers to go green. We'll show you how to choose the right thermal imager, as well as a short summary at the end. As I mentioned, we'll start with a very basic review of thermography. Thermal imaging is the non-contact detection and measurement of temperature differences, and from there we assign colors based on those differences. As you see in the bulleted list here, these are several things to be cognizant of when using a thermal imager. First up is emissivity. As you see in the picture of the iron, half of it is much warmer than the other. What's happening here is half the iron is coated in a black paint. This makes it a much more thermally friendly surface. Shiny surfaces like the left side of the iron are not very thermally friendly and lead to false readings. Thermal gradients deals with the heat transfer oftentimes through a fluid. So if you think of a gearbox, for example, with a lot of lubrication in it, the source of the problem or the heat generation is transferred throughout that, and the gradient spreads it out, so you're not able to get a true source of that problem, but you can see that there is one. Thermal capacitance refers to a material's ability to retain its temperature or its heat energy. We see this come into play on the picture on the far right of the tank level. Because water has a high thermal capacitance, it retains its temperature a lot longer than air, for example. So the air above the water within the tank allows us to see that fine line and the level within the tank. It's important to be cognizant of wind effects as well. If you have a strong wind blowing across the object you are inspecting, it is decreasing the actual temperature of that object. Angular variation refers to the angle at which we are inspecting an object. Ideally, you'd like to be perpendicular to the object, or as close to perpendicular as possible. And always be aware of your surroundings. Be sure that as you are performing an inspection, there is not a very hot object immediately behind you casting its heat onto the object you are looking at. Again, this was meant to be a very basic review of thermography. For more detailed information, please visit the Introduction to Thermography session. Thermal imagers are very useful tools to help determine the health of equipment. Now this session will focus on electrical applications, but they are also very effective to inspect electrical circuits, various mechanical equipment, heating and cooling equipment, the building envelope, various electronics, and there are several other applications for infrared as well. Here we have a list of the commonly inspected components. This includes three-phase power distribution, fuse boxes, cables and connections, relays and switches, insulators, capacitors, substations, circuit breakers and controllers, transformers, motors, and even battery banks. So as you can see by this list, there's tremendous opportunity to use a thermal imager within an electrical application. Here we see some typical reasons for temperature hotspots or deviations. This includes unbalanced loads, harmonics, an overloaded system or excessive current, oftentimes loose or corroded connections which increase the resistance in the circuit, insulation failure, component failure, in many cases it's as simple as wiring mistakes, and also underspecified components. Most electrical inspections are qualitative in nature. This means that we focus on temperature differences as opposed to actual temperature. Much of thermography relies on looking at the difference between like components under similar load conditions. There are some basic conditions that must be met in order to perform electrical inspections. The first of which is having a direct view. Thermal imagers cannot see through doors and enclosures, so it's important to have a direct view of the components you are inspecting. It's also very important to understand the present and future loading conditions of the equipment. Be sure that you're not inspecting a motor, for instance, that just turned on about a minute ago. Always try to inspect with the highest possible load, the minimum being 40%. Only qualified persons should gain direct access to live electrical equipment. Be sure to always consider the NFPA 70E and OSHA regulations, and always wear personal protective equipment. On this slide we see images of components commonly associated with three-phase power distribution. Now, as I said before, much of thermography relies on comparing like components. As you can see, certain phases are clearly standing out from the others. Now, we're unable to determine exactly what the problem is, whether it be a bad connection or perhaps an overload, but the thermal imager allows us to pick those out really quickly. Here again, we see how a thermal imager picks up on hotspots. Many of these hotspots are a result of a bad connection or an overload. By finding these problems and repairing them, there is quite a money-saving potential here. An awful lot of electricity goes to waste when a fuse or connection is overloaded. Cables and connections offer more of the same. You can imagine trying to spot these various issues with the naked eye. You'd never be able to pick up on this kind of heat signature, but the thermal imager makes it very simple. In this case, we see a high resistance connection which creates a localized hotspot. And here we have a few more examples. I'll take the time now to discuss the importance of trending and tracking these findings over time. Say you were looking at one of these connections for the first time. It would be hard to make a snap judgment on whether it needs service or not. If you come across a fuse or a connection running 40 degrees hotter than the others, it's probably worth taking a look at. If it's in the 7-15 degree range, probably not something that needs repair work immediately. Still capture that image, and on your next route, take another image and just track that over time to see if that differentiation grows over time, gets worse or whatnot, but just keep an eye on it. Not unless you see something major should you probably act immediately. This slide further illustrates the point about how quickly you can find things using infrared. If you take a look at the picture on the right, you see a functionality of the Fluke thermal imagers known as IR fusion. This combines an infrared and a visible light picture together. Now this is one viewing mode, but you can see how having that reference makes it very easy to pick out exactly which one you should be concentrating at. If you look in the upper right corner of that picture, you can see the number 129. IR fusion also allows you to read markers and labels that are on the target. Thermal imagers can be very useful when inspecting transformers as well. One thing to make sure of when looking to use a thermal imager for this kind of application is the resolution. Since many transformers can be 30, 40, even 60 feet away, many thermal imagers are not high enough resolution to get good temperature readings or even a clear picture. So make sure your resolution is high enough if you plan to inspect transformers. One of the major benefits of using a thermal imager here is that it can be done from quite a distance. When it comes to substations, resolution can be a factor as well. So make sure you have enough resolution to complete effectively the task at hand. Now obviously substations are the responsibility of the utility company to maintain. However, in many cases, companies that rely, as most, on a lot of power throughout the day will actually take their thermal imager out and just give the substation next to their facility a quick once-over, because they know if they're able to catch a problem even before the utility, it prevents them from having any downtime. So again, if they can catch a problem and have the utility company fix it before it actually fails, they have saved themselves some money. Some more circuit and lighting breaker images on this slide. Again, the thermal imager is going to quickly point out where a problem may be, but it is going to take another piece of test equipment to actually diagnose whether it's a bad connection, a loose connection, or an overload, something like that. The thermal imager will point it out to you, but it will take something else to actually determine the root cause of that problem. A thermal imager works great for motor controllers or MCCs as well. As you can see in the images in the upper left there, very easily trace the heat pattern going throughout those connections. Check the lugs on these and also make note of subtle temperature differences, as it may be caused by internal contacts that you can't actually see. Regular inspection of electric motors can add up to some major cost avoidance as well. If you take a look at the image on the left, what we're doing is getting a shot from a vantage where we're able to get all of these motors in a series or a row. This allows us to draw comparisons between each of them. Here, much of the inspection is qualitative and does rely on comparison to like and similar components. It's important to monitor the operating temperature of motors because uneven or excessive heat will reduce the life and efficiency of the motor. To give you an idea of the impact that excessive heat has on a motor, consider this. For every 18 degree Fahrenheit rise over the maximum rated temperature, approximately half the life of a motor is lost due to insulation failure. Now, the maximum rated temperature is specified by the manufacturer and should be on the motor itself, but right there you're able to see how much money can be saved by properly maintaining a piece of equipment like this. As going green continues to be a major focus for many companies, consider the following. Having loose connections, corrosion, or load imbalance resist the flow of electrons and cause connections or circuits to heat up. This is energy that you are paying for but getting no value from. Low oil levels, failing bearings, misaligned belts and shafts can all add to more power needed to drive your operation, again adding to your cost but not getting any value from. The reality is that a thermal imager can be your answer. Fluke thermal imagers are very easy to use. They will make you more effective, which means less firefighting and better preventative action. You will find thermal problems, solve them faster, verify repairs and new installations, and the bottom line is save money. The investment can be minimal, but the payback potential or return on investment is huge. When it comes to choosing the right one, in general, TI-10 and TI-25 are meant for basic inspections. The TI-40, 45, 50, and 55 FT tend to be meant for specialized or complex inspections. As you just saw, Fluke has several thermal imaging models to choose from to meet a wide range of needs. For more information, you may want to visit the product-specific webinars. You can contact your local Fluke rep or distributor, use the product selection tool on the Fluke website, or contact the Fluke Tech Support. Feel free to email us at thermography@fluke.com or call 800-760-4523. I'd like to thank you for taking the time to view this session, and please visit us at fluke.com/thermography.